with our statistics unit. And today we're going to start talking about the next step of our statistical journey. And it really, it is a journey through numbers. So up till now, we've talked about how we collect data, right? What a good survey looks like, what a sample is, what a population is, all that. So we talked about how we get our data. Yes? Excellent. After that, we talked about some ways that we analyze our data, some of the math we can do with our numbers. Specifically, what statistics did we learn? And some of this is old news, and others of these are new information. But what statistical tools do we use to analyze data? Mean, median, mode. Good. What else?
Range, standard deviation.
Range and standard deviation. Mean, median, and mode are what we call measures of central tendency. What the heck does that mean? What do they describe? It's a measure of central tendency.
Average.
Yeah, I mean, it's all different ways of telling us what the numbers in the middle of it look like, right? In the case of mean, it's like what's the number that's right in the middle. In the case of median, it's saying not what's the number that's right in the middle, but like if we took the person who's right in the middle of all those, what's his number? And then mode is the most commonly occurring number, right? But they're all ways of saying what's the middle of that data look like? What's that center of it look like? What do range and standard deviation tell us? What do range and standard deviation tell us? Sorry? How spread out the information is. Good. So if you have a big standard deviation, that means your numbers are very what? There we go. All right. I don't think that's true. Now, if the standard deviation is high, what's going to be true about my numbers? Yeah, they're spread out. Yeah, does it not do that automatically?
No.
No. Oh, you should totally set to do it automatically. That's much more power conscious. Because I set this so the screen never shuts off because I have to like teach with it, but man, does it eat through the batteries. Like it goes through them really quickly. Anyway. So we've done all of this by way of talking about how to analyze numbers. Today we're going to go to the next step. Caitlin? Little.
Hello.
Hey, listen, I appreciate you being here, but even though you're not in the class, you can't distract people with a screen during my class. It's not reasonable, right? Yes, great, we're all agreed. So today we're going to talk about how we take that data and represent it, how we can take our data and show them to people. And by the way, you did some survey, so you're going to have to do this.
Oh, I see.
There you go, gentlemen.
Okay, bye. Whoa.
Okay.
I almost smacked
So-
some green guy in the face for no reason.
I always support that.
They just got me off.
Okay. See, there you go. Okay. Dylan.
Yes, sir. Give me my paper. Look at.
Okay, there you go. Okay.
What the hell? Well, now I have two. Here you go, sir.
Thank you. Okay, so yeah. It is right here. So today we're going to talk about two distinct types of data and how we represent them. And these are terms you're going to have to know. Discrete data and continuous data. Okay. Dylan, I really need you to like look up at me and put your phone away. Okay. That's fine. That's fine. Say, Mom, paying attention to Orlando. He's so interesting. Doesn't have to be true. You just say it. You know, like, I don't know, dinner was good and it's terrible or something. It's just the polite things we say.
No, I
Makes other people feel nice. So discrete data. This is when we collect numbers. What does the word discrete mean? Does anyone know in math or science terms?
Keep it on the down low.
Okay, yeah, that's how we use it in everyday life. It's true, which is not what we're talking about here.
It's spelled differently in that scenario, though.
Is it?
I think so.
You might be right. I'm not a speller, if I'm being honest. I wish I were. I want to be a good speller. But when we talk about in science, here's what we mean by discrete. And it's kind of similar. It means that it's separate, that it's self-contained. Something that's discrete in science isn't connected to anything else. Does that make sense? And in numbers, we use it this way. Discrete data are numbers, are whole numbers that are exact. All right, and a good example of this would be counting numbers. And here's what I mean. How many eyes do I have? It's just me.
74.
Just me. 2, of course. Now, when I say that I have 2 eyes, does that mean that, is it possible that I have 1.9 eyes or 2.1 eyes?
What if one works better than the other, then you wouldn't consider it a whole eye?
I think you would still consider it a whole eye. So-
What if you have a glass eye? Yeah, exactly.
Okay,
That's only like half of it.
so I would argue then that that is not an eye, so you would have 1 eye.
But it says eye in the name.
Well, then I guess you have 2. Either way, you don't have 1.8. So listen, this is key. Discrete data are whole numbers that are exact. They're the counting numbers, all right? So these are numbers that can't be divided any smaller. All right, if we're counting how many people are in this room, we may not know the answer before we start, but we know that the answer is going to be a whole number. Does that make sense? There's no partial people in the room. That doesn't make sense. And again, I understand that you can say like, well, you know, like, well, if somebody were pregnant, is that part of the person? But in terms of science and math, when you count things, you get whole exact numbers, right? You can be like, I really don't like Orlando. He's only 2/3 of a person to me. So that's all well and good. But again, in terms of science and math, when we count something, it's a whole number. Does that make sense? Okay. Now, who can give me another example of something or a couple examples of things that we would count using discrete numbers? Like we could definitely say counting things. So fractions, actually, this specifically has to be whole numbers. So we're not talking about fractions here. We're talking specifically about whole numbers. Sorry? Sure. So I mean, money would be an example where.
What if that changes and that's not a whole number?
So even then, you have a whole number of quarters or a whole number of nickels or a whole number of dimes, right? Nobody can pay you half a dime. If you're talking about actual physical money.
Use like prime numbers.
If you're talking about physical money, yeah, prime numbers would be a good example. Another way we could get this is on a scale of 1 to 10. If you're only giving people the option of saying 1, 2, 3, 4, 5, 6, 7, 8, 9, or 10, you don't allow them to give decimals, you don't allow them to give fractions, then this would be discrete data. Does that make sense? No, I'm saying we don't allow that. On a scale of 1 to 10 where they have to pick a whole number. Essentially nobody? I don't know. I spent a lot of time in my life doing surveying, and that wasn't something that came up a lot. Especially like you give a Google form out there where they have to click a number. It's not really an option, right? Like they can click between them all they like. It's not going to do anything. So if they have to, well, I think a Google form is an actual survey. So again, no, I appreciate your engagement. I mean, I feel a little attacked, but that's okay. At least you're paying attention, Amy. And that's what I like. It's a shame that you're using it to like claw at my throat, but that's okay. No, it's good. No, but it is a good point. If somebody went in and put a decimal in, now you're no longer dealing with discrete data. They will, in fact, have screwed your system up. And that I should say that does happen. It does happen where you'll say on a scale of 1 to 10 and somebody writes in like 11 and you're like, well, that's cute. How do I put that in my database? Right? Because my database has numbers 1 to 10. So you actually raise a good point that when you collect data, you do have to be careful. Now, how do we arrange numbers like this? It's easy. You've been doing it since elementary school. If I collect a bunch of data like this, I can make a bar graph. So let's say, for example, I asked a bunch of people how many pets they had at home. How many pets they have at home. Is this continuous data or discrete? Can you have 2/3 of a pet? No. Listen, it's good to get these questions out. The fact of the matter is, if your pet has 3 legs, it's still a pet. If your pet is small, of course it's a whole pet.
If you're missing a leg. The leg is no longer there.
But like you're not saying like.
It doesn't make it less of a pet. And that's the point. Like, I get the instinct to want to go, well, what if? And that's good. But shh, we're not counting legs. We're counting pets. Now again, if I asked how many animal legs are in your house, then yes, if your dog was missing a leg, you'd have to say 3 instead of 4. But then you would report 5 instead of 4. But the fact of the matter is, shh, when we ask people to count something, they give us discrete data. They have to give us whole numbers. That's how counting works. So here, we can put this into a bar graph. And when I say a bar graph, what I'm really going to do is I'm going to figure out how many people said 3, how many people said 4, so on and so forth, right? So I want you to do a little tally for this. Can you tally the numbers up for me? How many people said 0? What's the highest number on here? 7. So 0, 1, 2, 3, 4, 5, 6, and 7. And just give that a quick tally for me. Let's see what we come up with. I know, right? But I guess not everyone loves pets.
My dog is so
Yeah. Okay, so go ahead, figure out those numbers for me, please. And please don't just copy me, because I have a habit of screwing up tallies every time I do them. So you really do want to keep track of this for yourself. See, I've already screwed up my tally. I'm not up to the job. Can I help you? Oh, sorry.
It's okay.
Okay, that's what I got. Did anyone get the same or different, or are you still going? You got the same? Good. I always like seeing how different people tally things up. I can't do it unless I go through and cross out.
Yeah, I got 4 for 1 too.
For which? For ones? Okay, let's take a look. I'm likely wrong. 1, 2, 3, 4. Yep, you're right.
You took away one.
Did I put it in the wrong place? Say, I'm not.
4, 7.
Okay, 1, 2.
That's just arbitrary.
Yeah, you're right. 4 2s. Wow. Did you get the same?
4 2s, 4 0s, 7 3s, 4
No, I'm just wondering how you do it. Do you just go up and count each one? Oh, cool. And you did a better job than I did. Well done. Okay. So, once this is tallied, how do I make a bar graph?
I don't know.
Good. So, we would do this. And we would very neatly, of course, 2, 3. How high is this going to have to go? Yeah, we'll go to 8 just for one extra. Yeah, I do actually. Okay. Now I am going to do, I'm going to do a relatively messy job here. You, of course, will do a neater job than I do. But how do I make a bar graph here? What do I do? What do I do? Oh, no, what goes on the bottom?
Nothing. I have no room.
No, the number of pets. That's okay. No, a little neater than that. Come on.
Already made it look like
It's really not. Okay. So now, obviously, to make the actual chart is simple, right? What do I do? How many people have 0 pets at home? 4.
that's a rip.
Now, here's one thing I want to make clear to you. When you make a bar graph, do the bars touch each other? No, they're separate. This is important. Nope, this is important. That's true. So this is key. That's right. So the bars do not touch each other. And the reason for that is that symbolically shows us on a bar graph that these data are discrete, that they're separate. That's why the graph is made to look that way, so that we know that these numbers are distinctly separate. Yes, sir. That's right. Yeah, so on a bar graph, they're separate. How many people had 1 pet?
Me.
Yeah, I did some boring data here. These are real numbers, by the way, from a survey that a student did last year. How many people had 2 pets? No. Handed into me becomes my intellectual property. Look at your student handbook thing that you sign at the beginning of every year. I own your work, kids. Well, not me, but the DSBN. How many kids had 3 pets at home? Yep. Very good. Yeah, the purpose right now is just to learn what it looks like when we get doing actual work. You'll have nice graph paper. Okay, how many people had 4 pets at home? Brody, sir, how many people have 4?
4, 3.
Very good.
74. This is my favorite number. 75 is mine, bro. 74 is the best.
Brody, how many people had 5? Very good. Dylan, what do I have for 6 pets?
Yeah, I was gonna say 0.
Good, how do I show that?
Don't leave a blank.
Perfect, very good. And 7?
1.
1. There we go. Okay, so that's a bar graph. Now, I would imagine that you've made a lot of bar graphs in your academic career, yeah? Okay. Now that you're a senior math student, one thing you need to be aware of is that a bar graph is a different thing from a histogram. And a bar graph is only used to represent a certain kind of data, specifically what we just talked about, discrete data, separate categories. The other thing about a bar graph is it can be used to define things that aren't even numbers themselves, right? If this had been how many people have cats, dogs, ponies, and chickens at home, down at the bottom we could have had cats, dogs, ponies, chickens, things like that, right? Anything that is discrete data, separate categories, a bar graph is the appropriate graph. And it really is key. One of the things we know is that if the bars aren't touching each other, we know that we are looking at a bar graph. And what kind of data is that?
Discrete.
Discrete. Good.
I'm so good at math.
You are good at math.
No. I had to be
Listen, Miles Davis got a C in trumpet class. You probably have no idea who that is. Do you know who that is?
Maybe.
Is that true? Wow. Really? That's crazy. See? So there you go. See, there you go.
Secretly 5'1" in high school, and then graduated instantly 6'9".
Listen, you laugh. I went to high school with a guy who was like 5'0" our entire high school career, and then we graduated. He was short as all get out, and then we all had grade 13. Then we came back from the summer after grade 12 into grade 13, and Tobin was like 6'3", and it's just like, what happened to you? It was unbelievable. So I think you're right, or he just won't grow, but he could.
If you saw David like my height, yeah. Comes here next year, bro.
He's just my height.
Okay. So here's what I want to do. Now I want to talk about the other side of the coin, which is continuous data. Now, anytime you see a decimal or a fraction, anytime there's possible numbers that could be a decimal or fraction. For example, if I asked you how tall you were, you would say not just 5 feet, but you would say like 5 feet and some inches, right? And if we had a really accurate measuring tape, we could probably say not just that you're 5 feet 4 inches, but we could maybe say you're 5 feet 4 1/4 inches. Does that make sense? And then if we had like an incredibly accurate set of calipers, you know, I have a set of calipers at home that go to the thousandth of an inch, right? Very, very, very accurate. I use them for setting up my guitars. So anytime we can get fine, really, really small decimals and fine fractions and cut that into more and more accurate pieces, now we're talking about what we call continuous data. Here's what I mean. When we talk about people being tall, it's not that you can be 5'1" or 5'2" or 5'3", and it's impossible to be that height in the middle, right? That's not how people grow. You don't wake up one day and you're an inch taller, and then you don't grow at all for a few months, and then you wake up another day and boom, you're an inch taller. That's not how growth works, right? It's continuous. You steadily get taller. And any numbers that work that way are continuous data. Anytime you're measuring the length of something, that's continuous, right? Because all lengths are possible. And if you have more accurate tools, you can get finer and finer decimals or finer and finer fractions. Does that make sense? It's kind of an esoteric concept. But continuous data is data where, and it doesn't mean you have to have a decimal, right? Maybe you are 72 inches tall exactly. It doesn't change the fact that somebody else could be 72 1/4 inches. Does that make sense? So it isn't even that your data have to be decimals or have to be fractions. It's just that if fractions or decimals are possible, that's continuous data. So I'm going to write that. So anything that we measure, anything you measure must be continuous. And that doesn't just mean with a measuring stick. If I use a thermometer, I am getting measured data, right? We use it to measure temperature. So temperature must be continuous data. And again, we know that, right? If you heat the oven up, it doesn't go from 20 degrees to 21 degrees, boom, right? It gradually, steadily, continually gets warmer. If I wanted to measure how much something weighs, you don't gain weight in 1 pound increments, right? You gain weight steadily, you lose weight steadily, right? So anything that we measure is continuous, and I'd say this too. Any data ranges are continuous. So you know how sometimes on a survey, oh, that's not spelled right at all. That's right. And what I mean by that is this. If I said how many pets, but this time, instead of just giving you an answer, I said 0 to 2, 3 to 5, 6 to 8, and kept going from there. Now, instead of being discrete, now these data are continuous. Because even though you can only have a specific number of pets, now that I've put them in ranges, that's continuous. Does that make sense? We'll talk about more. We'll talk about it more. So I think the easiest way to do this is to use an example. Does that make sense? Okay. So. Here we're going to make a histogram from marks in my math class last year. I taught a math class.
Oh, is this our class?
No, actually, this is.
I don't see it 32.
Oh, that is true. He did get 32. Okay, so here's the deal. We're going to make this a histogram because when we make a histogram, we take data and we divide it into bins. We divide it into those ranges. Does that make sense? Just like we said there, where with the pets, we could say you have from 0 to 3 pets, or from 4 and so on and so forth. Does that make sense? So what we need to do is figure out how big the bins we want to put in here are. Does that make sense? So sometimes we can just do that intuitively. If I'm looking at marks, I'm probably going to do from 0 to 10, from 10 to 20, 20 to 30, 30 to 40, and so on, stuff like that. Right? Does that make sense? Where it's really intuitive. Sometimes it isn't. So I'm going to give you a little formula you can use. You don't have to use this formula, okay? It's just if you're stuck and you don't know what to do, this is one way to do it, okay? Where what you can do, and you're going to use all round numbers. You're going to round, really round, all your numbers. Guys, shut up. Oh, that shouldn't say lowest, it should say highest. We can take our highest number, again, using just really round numbers, subtract our lowest number, and then divide by how many bins we want to use. It's not, I promise. It's really not. Let's look here, for example. I've got all these marks. What is our lowest number? What's our lowest number? What is it? 44. Good. What is my highest number? 95. 98. Sorry, pardon me. Shh. These are actual numbers, but I've obfuscated them a little bit. And it's not your math class. So we're going to use round numbers, and we're going to say this. If I want to know how wide I want my bins to be, now again, with marks, how wide do we always do them? Just 10, right? Like we always do 0 to 10, 10 to 20, 20 to 30. That's how you've always seen marks presented, right? But just to show you how we'd use the formula, we're going to round these out. So what's 98 round to? Yeah. So our biggest number is 100, and our smallest number is 40. And I want you to divide this into 6 bins. We're going to divide this into 6 different bins. Well, what's 100 minus 40? 60. And 60 divided by 6 is 10. Okay. So when we go to tally these, we are going to tally them in bins that are 10 marks wide, which makes sense. And then start with this rounded lowest number. So where am I going to start? At? Yeah, and we're just going to round it down to make it nice and easy. We're going to start at 40, and that bin will go up to 50. And then the next bin will go from 50 to... We're going to talk about that in just a moment. That's the right question, and we're going to talk about how we deal with that. It's a great question. From 50, we're going to end at 60. All right, and then 60 to 70, 70 to 80, 80 to 90, 90 to 100. And this won't apply, but we could have 100 to 110. Now, you can decide for yourself which side you want that whole number to fall on. Does that make sense? It's up to you. And you just have to be consistent. In this case, I want the number 50 to land in the 50 to 60 bin. Does that make sense? And I want 60 to land in the 60 to 70. In other words, I want that number included. So how we show that, and I'm going to make a little note on the side of this, is I'm going to put a square bracket on that left number in every case, which means that number, if it's that number exactly, it falls in this bin. And what do you think I use on the other side to show that that number doesn't fall into that one? Square bracket means that number exactly fits in this bin. So 50 is in the 50 to 60 bin. So I don't want it in this bin, so I would use, that's right, a round bracket. And that's the rule of thumb. All right, you could do it the other way. You could say that 50 belongs in the 40 to 50 bracket. Doesn't matter how you do it, but we always use the round bracket. Bin does not include this number. And the square bracket tells us that the bin does include this number. And as long as you're careful, it works. It doesn't matter which way you do it, but the number 50 can't be in 2 bins, right? If you had a 50 exactly, you have to decide where that goes. So the next bin always starts with the same number as the previous one because it's continuous. You can't start at 81, right? Because then what would happen if somebody had gotten an 80.3? Now it doesn't have a bin. Does that make sense? So what this tells me is start at 80. 80 would fall in this bin and go up to 90, all the way up to 90, but 90 itself does not go in this bin. It goes in the next one. Does that make sense? A little bit of sense? Again, it helps maybe when we actually get doing it. Okay, and now we're just going to start tallying again. Isn't it though? Oh, you meant it sarcastically. I'm being serious. So 68 goes in which bin? Good. And I'll let you guys keep going. And I'll do my own. And hopefully this time I won't screw it up. Though I probably will screw it up. Yes. Yeah, he's on his way. You're welcome. Can we get the same numbers? Yeah, I think we did. Hey, can we add a number so I actually have an example? And if I'd been smart when I made this note, I would have done this. Can we add 70 there? Because where's 70 going to go? Which bin? In the 70 to 80. And how do you know that? Yeah, specifically because it's got that square bracket. So I just want to do that so then I can put a little note here. See, you don't think of something when you're making the note and you're teaching the lesson, you think, ah, wish I'd thought of that. Oh, I know. Isn't that just the thing? You always think of the perfect thing to say as soon as you leave, and you're like, ah, why didn't I say that?
Normally I just say it unless you be like, oh, but by the way.
Fair enough.
And then the argument will continue.
Okay. So now, how am I going to lay out my histogram? What do I put down here?
40 to 50, 60, 70.
Yeah, and the way we usually show it is like this. Now, you'll see it done two ways, and I'm going to show you both. Okay? You'll see it done like this, where they put the numbers on the ticks. That is allowed. Or you'll see it like this, where in the space, they say 40 to 50, 50 to 60, 60 to 70, 70 to 80, 80 to 90, 90 to 100. I have no preference for what you do. Can I tell you the way I do it? Because I think it just looks nicer.
Yeah, but I feel like
I do it this way.
I feel like that could do like half numbers, and then you have to go in between them.
Well, no, because it means this range means between 40 and
Oh, so you
50.
put the bars in between.
And then I put that's right. And then I put a square bracket here to show that that 40 is included in the first one.
Okay.
So this is how I do it, but it's not the only way to do it. Now, a histogram is continuous data. And to show that, when we put the bars in the histogram, we make them,
All together.
they make them touch. So how many were between 40 and 50? 1. How many were between 50 and 60? How many were between 60 and 70? How many were between 70 and 80? Oh,
look at that sky.
now let's see how your Spanish is.
No, those Ocho.
Ocho, very good. How
I learned
many-
that from Handy Mandy, actually.
How many people were between 80 and 90? How many between 80 and 90?
80, 90 is 6.
Very good. And lastly, between 90 and 100.
Dose.
Dose. And I didn't even bother putting a bin between after that because there's nobody in it. Does that make sense?
Right.
And then I'm going to fill this in just so it looks pretty, because why wouldn't I? Yeah, no, they did. We don't watch much TV because...
You're one of those.
No, you know what? I'm not one of those at all. I have no problem. Can I tell you what my problem with TV is? It's not TV. I like TV. I like watching TV.
The commercial.
It's the commercials. I
I
go insane watching commercials. It just makes me feel crazy.
never watch TV shows while they're on TV.
Yeah, you
I
record
always
it, right?
record them.
Yeah. Exactly. Yeah.
So I can play it live, or I can like wait 15 minutes.
Exactly.
Yeah, that's
Yeah.
what I do.
So it's even like I like to watch football. I always record the game, wait till an hour and a half into the game, watching it, and you can just skip all the ads because football's the worst. Like you put this game on, and just every 35 seconds, it cuts to commercials. It makes me feel crazy. Well, the Super Bowl, you want to see the ads. Yeah, it's totally
I never
different.
got that. I really never.
Oh, they're fun ads. They're good ads. Well, the thing is, you have to get the American stream because our ads suck. You got to get.
You know what?
Well, there's that.
Americans and Canadians just have the same stuff.
Yeah, why can't we just merge into one country?
Well, especially yeah, you see their Netflix and they have like every movie imaginable, and then ours it's like 3 hours of stuff you don't want. Okay, so let's take a look here. Shh. This is a histogram. Histogram shows you the same thing a bar graph does, but the data is in ranges. The data is in ranges. Can we stop to just admire how excellent my histogram is? Like, let's be honest. Listen. Listen.
Is it better than mine?
Listen. I'm not saying it's perfect. I'm just saying it's very good.
So live done straight on the top.
Of course you did.
Of course I do.
I mean, you're difficult, and I like that about you.
I have to color it all right.
Is that left-handed?
Yes.
And you're right-handed?
Yes.
That's really good. I'm impressed.
I always have to color in the spaces because they're all.
Can I tell you the nice thing on this is you can use the highlighter to color it, and it doesn't cover your black lines. Yeah, it's nice.
It looked like kindergartners did it. It was when I went right-handed, it ends up being like.
No, it looks reasonably neat. Reasonably neat. Okay. So does this process make sense?
Yeah.
We take our data, we divide them into bins. We divide them into bins, and then we put the tallies up. Okay. So I want you to do the same thing, and you know what? I want to actually.
Oh, what's that?
Okay, what happened to the whole, I'm not gonna give you a lot of numbers, because I'm not mean like that.
This
Because.
because
I'm cheating, I'm gonna send this to Tristan Griffiths, and this should come back all clean.
oh, you're so right. If you sent this to Tristan, he would send you like. Can I tell you? I think Tristan is probably one of those guys who keeps box scores at home, like actually has score sheets and keeps them.
Yeah. I'm gonna send it straight
Okay,
right now.
so here's what I want you to do. You don't have to use all the data. You may want to use a ruler and highlight it. We're just going to talk home runs. We're just going to talk home runs.
I'm sending it to Tristan.
That's awesome.
John ripped my game.
No.
I did not.
Yeah, look at my knee.
Look at my knee. You ripped my knee open.
We'll never know. How many times have they been sent to human resources? Okay, so here's what we're gonna do. And we're gonna decide this as a group. How many bins do we want to divide this in? I think let's do 5 bins is good. What's the biggest number on there? So maybe it would be nice to do 6 bins, right? 6 might work nicely. Because then what's the easy way to do them? Because, I mean, we could do anything. We could do 0 to 7, 7 to 14, 14 to 21. Is that going to be fun and nice and easy to work with? Yeah, exactly. So I would say if we do this in 6 bins, then we can go 0 to 10, 10 to 20. Now, I want you then to do that. Just like we did last time. We're going to go through here and make a histogram of these fine fellas. Oh, yeah. So I'd do a tally down below. I'm not easily bought.
I'll get you a double.
Because here's the thing, I get paid pretty well at my job, so if I'm gonna endanger it, you're gonna have to make it worth my while, kid.
Honestly, you still get. Okay, Orlando, double in a Boston cream.
Honestly, you can go around and you can see
Photo math, I'm gonna grab it. So it's just helpful. What are you trying to do?
I can assure you, photomath is not gonna make a histogram of this for you. Now get to work.
It'll give me numbers. So I can
Oh, there's ideas.
Sorry? Just for me, it's hard to fit between the 2 pages. So you guys, being more clever than I, one of you can call off the numbers, and one of you can do, right? You can be a team.
Once I can't go. Hopefully something I.
Oh my God, there's an Escobar.
Yeah, so you two can do it.
Jake.
You know who that is? You know who Pablo Escobar is? You're either proud. You see that?
And he's still going to be very encouraging. Yep.
Mr. Orlando, I don't understand. There's a 2.
Mr. Orlando.
Oh, never mind.
Can you better explain who Pablo Escobar is?
Yeah. So I don't know. I mean, famous drug lord, right? The head of the, was he the head of the Medellin cartel?
Yes.
That's all.
Why are we talking about the cartel last time?
So I already know it's history. I watched documentaries on it.
Oh, the one on Netflix?
No, not just one of those.
Okay.
It's easy.
Because I always see the one on Netflix, and I always think, I should watch that. That sounds interesting.
Narcos is also a good representation with like the drama.
I've heard it, but yeah.
I should just watch it. Sorry.
Let's watch a documentary.
Yes.
Yeah.
Or we could make a histogram. Get to work, buddy.
You're Friday.
Is this the end of the note?
No. What? Are we tallying or what? What are we doing?
We're looking at our students.
Come on, get to it. Come on, go. Yeah, I took the entire Major League and then I just sorted them by most at-bats. So you're going to be with good players, right? Because they're not.
Explain this guy. 653 at-bats, ranked 2, but only 2 home runs.
That was the home run hitter. I wonder if. Who is it?
This dude is Florida.
Show me. I wonder if it could be a pitcher because in the he's got a good average base hitter. And bat and DLA. Listen, can I tell you something? And this has nothing to do with baseball, or nothing to do with math, but just on baseball. I think it's a shame that we've entered the home run, the slugging era again, where I guess as entertaining as it is to watch people rack up their home run averages, it leads to 2 things. Long games with lots of strikeouts and the occasional home run, and really, really slow play. Pitcher's eye, batter eyes, pitcher up. Like baseball has never been slower than it is now. And I'm a big believer in small ball baseball. Give me the line drive, get on base, you know, and then see how your base. Anyway. And this is what I mean, yeah. So it's. I read an article, so I subscribe to a website called 538, which is all about statistics in politics, sports, and such, but specifically the passion of baseball. And they have been postulating that part of the home run era is that the Major League changed baseball sometimes about 6 years ago. And they've statistically shown that after that change, the new balls are just a little bit springier, a little bit more distance on them. And the thing is, when you're talking home run hitting, a little bit of distance is the difference between an easy fly, right, and a home run. So, yes. Oh, so you're all done except for, you know, being done. That's right, Newberg, I can be snarky too. Oh, two-way street, kid.
You can always ask Tristan what it's like baseball games, because I mean, he goes to every single one of them.
Yeah.
He doesn't know when he was from in like a mini army, and he's still on my Facebook, so they're not paying $20 for gas.
I don't know what to tell you.
I mean, gas money's gas.
Yeah, can I say, everyone's got to pony up for gas money. You're going somewhere, everybody.
I was in a really desperate ride home. Stop.
That's sufficient, thank you. Okay. Guys. Subtlety's never been your strong suit. Guys. You'll get there. So you Italian?
I'm getting.
You Benz?
Yeah.
So here's a case where I wouldn't use the formula. I'd just use common sense. Your lowest is close to 0. Your highest is close to 60. What's going to be the easiest way to do this? 0 to 10. So when I said I showed you a formula, we're going to use that when we do some cases where the numbers are kind of messy and ugly. When the numbers are nice like this, just stick with it. Hint, I may be asking you to do the batting average for homework. 33, 20. What?
This isn't in my contract.
You have a contract?
Yeah. I signed it.
37 to 3.
Calculated.
And these are real data. Isn't that interesting? Yeah.
No, that's not the answer.
So very mean for you to do.
Oh.
You've been telling us the whole time.
Come on, get to it. Listen, there's a time and place in life for a little bit of work. Now get doing it.
That workplace is work.
Okay, John, remember the other day you said you'd come to
You're doing pretty good.
Where you
You're slow.
would recommend
You just like stuck there.
everything.
Are they hiring?
No.
We're not hiring people that don't do their work, I can promise you. Now get to it.
I don't get
I'm trying to do my work and they're just.
Take my pencil. Arthur, give my pencil back.
All right, what do you got? You got numbers for me?
Yeah.
I'm trying
Let's see if they match.
But he just pulled my paper off the desk.
So I have 4. What do you have for the first one?
4.
I have 6. What do you have?
6.
I have 12.
12.
I have 10. I have 0.
0.
And I have 1. 4, 6, 12, 10, 0. 4, 6, 12, 10, 0.
Thanks, Sarah.
Okay. Now that you've got your tallies done,
Oh, I made a.
come on, sit up. It's okay. You don't need to. I put one on this page so it'll be next to the graph. I made one here because it was easier to work with.
Can I just like fill in the numbers? Or
Oh yeah, yep, absolutely. Okay, shh, guys, thank you. Now that we've got our frequency, how do I turn this into a histogram? What do I have to do? Mr. Fowler, what are you thinking? How am I going to turn this into a histogram? What do I have to do with my axes here? Sure. So what's going to go on the bottom? Yep. So what should my next tick be? 0 to... Yep, next. Good. Good. Yeah, and if you went to 70, obviously there's nothing going to be in there, but that's fine. And then what am I going to do going up and down on this axis?
1.
Yeah, how high do I have to go? Sure, perfect. So I'm going to try to be careful here. 1, 2. Obviously, I would use a ruler or graph paper if I were trying to be really accurate. Yeah, when it gets really warm, the fan, they try to make it really quiet, but the result is it has a really like awkward high pitch. Oh, all of a sudden that's a 90. That doesn't make any sense. It's kind of awful, eh, that sound? So I took mine to 12. If you went to 13 or up to 15 or whatever, nothing wrong with that. And then I'm going to go like this, right? Anyone going to yell at me?
Okay.
That's right. And they should be, right? Guys. Oh, that was not good.
Are you lying? Are you lying? That's what I'm getting out of this conversation.
There's nothing there. We just leave it up to you.
That's exactly right.
Yes. Sorry.
Yeah, that is okay. Oh gosh. All right, there we are. And there is my histogram now. Thank you. Does anyone have any questions about that? It's not that terrible a process, is it? One thing I want to say is here, we're going to get some data. I want you to imagine that you have a puppy. So you get a dog. And every month, you're going to track how much weight it gains. That's important. Yeah, it's important. Now, what do you notice about these data? There's a negative. Is that allowed?
No.
Yeah, it means the dog lost some weight. 0.2 kilograms specifically. So here, you guys, the last couple examples, the bins were really obvious. Here, how low down do we have to go?
The negative.
Yeah, all the way. Our lowest number is negative 0.2, and our biggest number is
0.6. Oh.
and we got a 1.6. We got one big month in there. So there's a lot of different ways you could do this. I think I would do it like this. I would say I don't want to have like 30 bins. I maybe want to count by 0.5s. If I do that, how low am I going to have to go? Yeah, so I'm going to go for my lowest, negative 0.5. And what's my highest going to have to be? Very good. So again, I gave you that formula on the other sheet, but that's not always the best way to do it. Sometimes the best way to do it is just to take a look at the numbers. Does that make sense? So make yourself a tally chart, make yourself a histogram. Let's see what we get. All right, get to it. Wallington's such an artist at heart, always with the sketched lines. Yep, but what I'm saying is I want to not have weird bins. I don't want to have to go like from negative 0.2 to like 1.1 kind of thing. So I'm going to go by 0.5s. We're going to make our bins that wide. In which case, how big will my first bin be? Where is it going to go from until?
Negative 0.5 to 0.
Very good. Negative 0.5 to 0. And it doesn't matter. Do we want to count which number do we want to include in this bin? The 0.5 or the 0? Where do we want to put that square bracket? The negative 0.5. So we'll include that number, and the 0 actually goes in the next bin, right? And the next one would go from 0 up to, yeah, up to but not including 0.5. And the next bin would go from 0.5 up to but not including 1. Very good. I'm going to put 1.0, but you could just put 1. The next one will go from 1 up to and including 1.5. And Tanguay. Yeah. How big is my next bin? It's going to start at 1.5 and it's going to end at. Yeah, very good. Okay, so let's go a minute and tally this. Let's go a minute. That doesn't make sense. I'm just talking at this point. Sorry?
I have the extra two boxes. We have 0.0, 1.0, 1.5. There's only 1.6.
Yep.
All the other.
Yep, you may have some empty ones, and that's just how it goes. Because it has to be continuous, and they have to be evenly spaced. Does that make sense? So it's just like here, where we divided how many home runs they'd hit. Nobody hit between 40 and 50, but so the scale goes continuously, so the scale is even, we have to put it even if no data goes. That's a great question, by the way. It's exactly the right question to be asking. Does that make sense? Cool. 6 puts us here. Brody, sir. Brody, sir. Have you done this? Yeah. What's your tally for the first one?
1.
What's your tally?
1.
Yeah. What's your tally for the next one?
5.
Next.
3.
Next.
0.
Next.
1.
I meant to go in and add a mistake, and then I forgot to. That's disappointing. That's okay. Get to work. It's like when I taught, the first time I taught grade 10 science, I gave everyone homework and said they had to look the answers up online. Then I booked it over to Wikipedia and changed all the answers so that they would all get all the questions wrong. I was quite proud of that. I thought that was pretty creative of me. Then I got my Wikipedia account suspended. So it's kind of a one-time trick, because it turns out if you go onto a Wikipedia page and intentionally change all the answers, all the information so it's not true, Wikipedia frowns on that. They don't like that. So yeah, they banned me. So I could only do that trick once, but man, did I have fun doing it.
Just like, how many people got messed up because of that? How many
Like, what if a number?
No, you know what? I picked something intentionally that was very obscure. Nobody was talking about this stuff.
How do you know? What if there's some scientist major who's studying for something midterm?
Listen, can I tell you something? Despite what you may have heard, Wikipedia is amazing. It's a great resource. Yeah, here's the deal. Shh. You can't cite it as a source, right? If you actually want to like write a paper, sure, you've got to actually find proper sources. But in terms of learning something you don't know, Wikipedia is amazing. Well, there's that. And I will be the first to say they were right to ban me. I was in the wrong. They were in the right. But I still thought it was funny. He's being quiet. What's so bad about that?
He doesn't want you to
So,
know.
Okay. I want to make a note. Guys, make note. Which bin did these go in? Which bin did they go in?
The one.
0.5 to 1. Because that square bracket tells me that this bin includes 0.5, but the round bracket tells me this goes up to 1, but does it include 1? No. What bin does this go in? Very good. And I think those are the only ones that are spot on, right? Well, I'm going to use colors this time. I've been so boring so far. Too excited. I know, right? Orlando with his fancy colors. Ah, what a guy. Wow, that line was... You know, there was always that kid in kindergarten with the 64 pack of crayons.
A week after school starts, all the friends are gone.
Yeah.
You gotta get the classroom box.
It's like every year I buy a big old thing of Sharpies. The whole thing of Sharpies just disappears. Ugh. A whole box of pencils. I think...
You showed me Lockies that you look like there's a full box.
Was Tim selling illegal pencils? Black market pencils?
I still have it. Tim steals everything, bro.
Okay. How's that look, guys? Not that great. It's beautiful. Yours looks nicer. I will grant you that. Lackluster? My other one was better. What? Okay, so the thing is, if you look at my screen, it's very colorful. It's the contrast setting on that projector.
Yeah, have you ever noticed that after eating a bunch of veggies,
Oh, no, we can do it this way. Ready? I'll help you. We'll be a team.
I was just going to say color polka dots.
Oh, polka dot it. Oh, I like that.
They're complaining about colors.
Oh, that's cute. See, you're so much more creative than I am.
Honestly, I can't. You should see the mural. I took on my favorite drawings and put them on my wall.
I'll give you $5. You give me 10 minutes.
Okay. Now.
Ready, bro?
Your homework today. Oh no, you have 2 pieces of homework. 1.
I cannot. If I ever touch the politics.
I still don't know how to say
You know what? This has no textbook work on. Make a histogram for.
No.
Oh yeah.
No.
Yep.
No.
Yep.
No.
Yep. And it's ugly. It's decimal number too.
I'm actually gonna stress
Oh.
about my.
Oh.
Oh God.
Okay. I support that. Make a histogram for averages. Yeah. No, you're not.
You know, they're gonna come in, since I'm not on guns, they're just gonna come in with 26.
Okay, and then you're gonna have to do this sooner or later. Might as well do it sooner, because then we can talk about it. Make a bar graph or a histogram, whichever is appropriate. And keep in mind, you have to pick which is more appropriate. Is my data continuous or is it discrete? It's discrete. Make a bar graph or a histogram for your survey data.
Yeah.
Well, you need to do that because that's going to be your big submission for this unit. There will be a bit of class time for it. But like the survey itself should be done by now.
Yeah.
So you should tally them. See how we did a tally here? You should tally your data. Yes, you need to do that. You guys cause me so much stress.